Hey guys, Miss Williams here. So I wanted to talk to you guys yesterday. You should have completed the assignment. Um, I'm trying to think of, where you watched the video to introduce you to rocks and minerals. And today I'm going to go over the PowerPoint that I have been giving my students. They've been taking notes. Anything that's lit up in red, they had to write down. You guys obviously do not have to do that. You can view this as many times as you want. You can start it and pause it. But we are moving on to minerals and rocks as well. But first, we're just going to focus on minerals and mineral identification. I want to go over some of your learning goals for this unit. You are going to be able to explain how minerals are identified, describe how color, luster, and streak are used to identify minerals, explain how the hardness of a mineral is measured and determined, describe the properties of cleavage and fracture, identify additional properties that can be used to identify some minerals. So those are your learning goals for just this mineral unit that we're going to be focusing on for right now. And after you watch this, you are going to have a worksheet to fill out. And sorry, I heard something in the hallway. And it will be due, let's say today is Tuesday. That will be due by Thursday. Okay, so this first slide is the rock cycle in Earth's crust, and it looks really confusing because there's a bunch of arrows everywhere, right? Well, the reason why there's arrows everywhere is because the rock cycle is a continuous cycle. It never stops, and it happens inside of the Earth's crust. Minerals and rocks. So the solid crust of the Earth is made up of all these rock-forming minerals. The definition of a mineral is a naturally occurring inorganic substance with a specific chemical composition and physical and chemical properties. Rock usually consists of more than one mineral and may vary in composition. So let's look at the differences here between a mineral and a rock. One of the major differences is that a mineral has a specific chemical composition, but a rock can vary in composition. Vary comes from the word variety. So there's going to be a variety of different compositions. Composition is what something is made up of. So minerals are made up of a specific composition, okay? And a rock is going to vary. A rock is going to be made up of many different minerals. Rocks, as I just said, are made up of different minerals that can be made up of more than one, but a mineral is only made up of one type of mineral. I'm going to skip this slide. There are 2,000 minerals, but only about 10 of them make up most of what's inside the Earth's crust. Minerals are identified by both their mineral, which just means physical and chemical properties. Physical properties are things that we can visibly see, and chemical properties, we may have to put a chemical on the mineral to see if it reacts to that chemical. We're looking for a chemical reaction. This is what we use to determine the hardness of a mineral. Now, when we're talking about hardness of a mineral, we are not talking about, if I pick up this mineral and throw it at my brother, is it going to hurt if it hits him in the head? We are talking about the resistance to scratch, okay, or the resistance of being scratched. So if we look at the scale, at the bottom is talc, which is a 1. Okay, that means it is soft. It's not very hard. If we look at the common objects over here, this common object shows us that somewhere gypsum and calcite is going to be about as hard as your fingernail. So gypsum and calcite are pretty soft, which is why there are 2 or 3. As the scale goes up, these minerals get harder. So if we look, the hardest mineral is a diamond. Okay, so topaz could not scratch a diamond because topaz is not as hard as a diamond is. But a diamond could scratch all of these minerals underneath of it because a diamond is harder than all of those minerals. Sorry, that just kind of looks blurry, the camera. Let's talk about what physical properties are. So hardness, as I just said, it's the ability of a mineral to resist scratching. The hardness of minerals is established by using that scale we were just looking at, which is called Mohs scale of hardness. And as I said, the higher the number on the scale, the harder the mineral. So if there is one mineral at 9, then that number 9 mineral can scratch all the minerals below it. Okay, but it cannot scratch any mineral above it. The word cleavage here means the directions a mineral splits. So if we look at the mineral and we look at how it is split, that is the cleavage. And what we're looking at is the direction of the split. And here are some examples. So a mineral may break or fracture, leaving an irregular surface. And we're looking here to figure out the irregular surfaces. Streak is the color of a powdered mineral. The way we determine this is we get a piece of white porcelain. If you've ever seen a porcelain doll, this is what those dolls are made out of. We get a piece of white porcelain and we take the mineral and we strike it across the porcelain to see the streak color. The reason why we do that is because a lot of times the color of the mineral is not the same as the streak that it presents. So the streak can differ from the actual surface color, as we see here with cinnabar, right? Cinnabar is black, but the streak, when it's striked against the porcelain, is red. And if we look at pyrite, pyrite is usually known as fool's gold. It has that gold metallic luster, but when we streak it, it's black, okay? And although there's some black in the mineral, it's not its actual color. Luster is another way that we determine or identify a mineral, and luster is the way a mineral reflects light. We're looking for, is it metallic or non-metallic? Metallic means shiny, and non-metallic is matte, okay? We also look at color, but color is like the last resort that we look at. Like if we're down between two minerals, we've went through all the physical property tests, then maybe the last thing we look at is color, because color is a poor basis for identification, meaning we cannot rely on just the color of the mineral, because many minerals are colored by impurities. Okay, impurities are things that don't actually belong in the mineral, but can get in the mineral from going through the cycle so many times, or maybe laying in a certain spot outside for so long, can cause the mineral to have impurities. And so it's going to have a variety of colors that may not actually be true to what the mineral itself is. We also look, most minerals have a definite geometrical shape. Some of them look like crystals, and I'm sure you've seen this if you've ever went to a place that had the cool minerals that you can buy, right? And you could see all the crystal formations inside of them, or geodes have crystals inside. We can also determine what a mineral is, and this is a physical property, which kind of mineral it is, by the density, okay? And density equals mass divided by volume. The density of any uniform sample is going to be the same. So the density of pyrite is always going to be the same no matter the size of the sample that we have. The density will always be the same. Let's talk, one chemical property that we can test is the acid test. If a mineral or a rock is a carbonate, okay, and I'll tell you what a carbonate is in just a minute, there's going to be a bubbling reaction whenever we place that hydrochloric acid onto the rock. Of course, we're going to dilute that hydrochloric acid a little bit to take the strength away from it, but when we put it on the rock with a dropper very carefully, it's going to bubble up. Okay, carbonate is just a mineral containing carbon and oxygen, which is where we get the word carbonate. The acid test is often used to test for a limestone, rock, marble, rock, or calcite. So how are minerals formed? Most minerals form far below the Earth's surface from crystallization from liquid magma, right? It's going to cool. That liquid magma is going to cool and crystallize, and we're left with minerals. Some minerals are formed from solutions, like when natural bodies of water evaporate. And new minerals may form from the chemical weathering of rock. And we're talking about chemical weathering, not physical weathering. An example of chemical weathering is like acid rain. Sometimes there are areas where acid is present in the rain. Minerals are non-renewable resources. This is very, very important. A non-renewable resource means what was present on the earth when the earth formed is what we're left with, okay? We cannot make minerals. They are non-renewable. Okay, so now I'm going to show you guys the paper that you are going to be doing. Hopefully, it should be up somewhere. Let me find it very quickly. Okay, this is the worksheet that you are going to be doing after you watch that PowerPoint that I just went over. It says choose the response best completing each statement or answering each question. Base your answers to questions 1 through 3 on the table below and on your knowledge of science, what we just went over. If you need to, go back in the video, because my traditional students in the classroom were able to use their notes. So if you guys need to go back to the PowerPoint to re-listen to it, that's completely fine. This table shows some physical properties of 4 minerals. So the table is labeled. This is showing us the physical properties of 4 minerals. We have physical properties. This is the mineral name. This is the luster, okay, shiny or not shiny, metallic or non-metallic. This is the density, the color of the streak, the color of the actual mineral, which remember is a poor way to identify, and the hardness. And this is just going to say if it's hard or soft. It's not going to give you a number from that Mohs scale of hardness. You do not have to do number 2. You do not have to do number 2, okay? Okay, so I want you to complete all of this, and when you get to this part, it's going to ask you about the procedure of how to test a streak. Remember how we test the color of a streak is by striking the mineral on a piece of porcelain, and that will tell us the color of the streak. Now, when you guys do this worksheet, what I want you to do, that's not the right one, hold on. What I want you to do is make sure that you make a copy of the worksheet. So on yours, I believe it's a little, it looks like a little pencil in a box. If you click that, you can make your own copy and type on it. And when you do that, then you can just, when you hit the turn in button, that copy, I can automatically see that copy. Okay. But you need to make sure that this gets to me by Thursday. All right. Have a great day. I will be in contact with you. If you ever want to join in my class, you can get with me about a time that works best for you, and I can put you on. We can do a live, and that way you can listen to a lecture. Okay. I'll see you guys soon.